Hello guys, I'm glad to see you in our chemistry lesson again, and today we continue our alcohol topic, discussion about our alcohol topic. And now I would like to show you some pictures. What is your associations when you see these pictures? I think that the first your thoughts are about the golden rule of drivers. Having to drink an alcohol before or during the driving a car. It's a good idea. However, today we will speak about another thing. And now, as a hint, I'm going to show you the short video.
Most of the world needs to reduce its dependence on oil and gas. By 2020, it wants 10% of energy used in the transport sector to come from renewable sources. In order to meet this target, manufacturers have been developing cars which run on alternative fuels such as electricity and biofuels. Biofuels are byproducts of industrial waste, for example gases, alcohols, organic compounds and oils. They originally come from vegetable or animal matter. There are two main types of so-called first-generation biofuels. Biodiesels, made for example from rapeseed, sunflower or soybean oil, and bioethanol, produced from plants such as sugar beet, sugar cane, cereal crops, wheat or maize, and blended with diesel. The advantage of this alternative energy source, it helps reduce greenhouse gas emissions. The biochemical method typically uses the cellulose found in plants to ferment ethanol.
Did you know before this lesson that ethanol are used as a biofuel? As you guessed, the topic of current lesson is the manufacture of ethanol and usage of ethanol as a biofuel. Learning objectives of the lesson. Understand two main routes for ethanol production and the advantages and disadvantages of each. And the second learning objective is understand environmental issue, inducing those bioethanol fuel, and understand the concept of carbon neutrality. By the end of the lesson, you will be able to know that ethanol can be made from ethane and steam, or by yeast. Compare the environmental impact of producing ethanol from renewable and non-renewable sources. Before we start to discuss about main ways of manufacturing ethanol, let's introduce with key terms which we use during the lesson. Please match the pictures with corresponding terms. For this task, I give you 1 minute. Are you ready to check your answers? Let's check. Dear students, let's remember about what organic classes we have already discussed this year. Yes, you should exactly know the properties of alkanes and alkenes. Please suggest me the way of obtaining ethanol. As you predict, we can make ethanol using hydrolysis of ethene. The mechanism of this reaction is electrophilic addition mechanism. Please revise each step of this process. Let's revise the mechanism of this reaction. First of all, let's look on our molecule of ethene. As you know, molecule of ethene has double bond. One of the bond is single, sigma bond. It's strong bond. The second one is a pi bond. It's unstable and could be easily broken. I represent the pi bond as a pair of electrons. By the influence of proton, which come from the catalyst, as you know, phosphoric acid, the pi bond broken heterolytically. So Through this bond pair, our proton is joined to one of the carbon. At the second carbon formed the positive charge. At this stage, we obtain the carbocation. This positive charge attracts the lone pair of oxygen in the molecule of water. As you know, in molecule of water, oxygen has two lone pairs. So one of the lone pair attracts to this positive charge and form one bond. The positive charge from carbon transferred into oxygen atom. This particle is unstable. To achieve stable state, this particle removes the hydrogen cation and release our catalyst. We obtain the ethanol and proton as a catalyst removed from the reaction. Now you can see the flow chart of the process. The main resource is ethene. It comes from cracking heavy fractions of crude oil. And as you know, this resource is final. According to the experimental investigation, the following conditions was established. The ratio of ethene to steam, gaseous water, could be 1 volume to 0.6. This process requires high temperature and pressure. That makes this way more expensive. The catalyst of the reaction is phosphoric acid. Through one pass of reagents through the reactor, only 5% of ethene converts into main product. At the last stage, all gases are cooled and ethanol are liquefied and unreacted gases returned back in the reactor. Such industry schemes are called as a flow process and give the possibility to achieve an overall 95% of conversion. Let's revise our starter video. What way of making ethanol was mentioned there? Yes, the manufacture of bioethanol using yeast fermentation of sugars. Have you ever observed this process in domestic conditions? Usually you conduct this process when you want to prepare the dough for bread or cakes. During the fermentation, one molecule of glucose are decomposed into 2 molecules of ethanol and 2 molecules of carbon dioxide gas. Ethanol fermentation is a biological process by which sugars such as glucose, fructose, and sucrose are converted into ethanol and carbon dioxide in the absence of oxygen. And now, time to do experiments. Today we repeat fermentation process in the laboratory conditions. For this experiment, we need 5 grams of yeast, 20 grams of sugar, 20 grams of fine chopped beets, 150 milliliters of distilled water. The temperature of water approximately 40 Celsius degrees. Also, we need 2 conical flasks, balloons, and funnels, and glass rod. Okay. First of all, let's number our conical flasks. Number 1 and number 2. In the both of these flasks, I add 150 milliliters of water. At the first flask, I add table sugar. At the second flask, I add fine chopped beets. I think, dear guys, you know that table sugar are made from the beets. Now, let's see the video.
Sugar starts with sugarcane, a tall tropical grass that can grow up to 20 feet high. When it is ready for harvest, the tops are removed, leaving the base stalks behind so they can grow into the next crop. Sugarcane is a renewable resource that doesn't have to be replanted to produce a new crop. After harvesting and transporting to the mill, the sugarcane is washed and cut into shreds. Next, huge rollers crush the cane, really hard. This mixture goes down to the separators, where the fibers are removed and the juice is sent on to the evaporators, which are basically huge pots heated by a furnace burning the dried sugarcane fiber. How efficient is that? This syrup is thickened by boiling off the water. Once the syrup is cool, it is time for it to be crystallized. To get crystals from the syrup, it is seeded with, well, crystals of sugar. Just a sprinkle is enough to kickstart the process. From there, it is moved into centrifuges, where centrifugal force squeezes out any remaining liquid, leaving, you guessed it, dry sugar crystals. Now the crystals are purified, decolorized, recrystallized, and dried in a large granulator. Next, they are sized by running them through a variety of screens, all to remove any impurities and make the sugar crystals just the right size and color. The end result is pure cane sugar.
Let's prepare the solution. Now, let's add our yeast in the both of these flasks. Dear guys, how do you think, what is this yeast? For exactly answer to this question, let's see the video.
Yeast is a fungus, and there are about 160 known species of yeast. Yeast is very small. 1 gram holds around 25 million cells and has been used for thousands of years to help bread rise. But how does a fungus help bread rise? It has to do with what yeast eats, how they metabolize that food, and what waste products are released. Yeast feeds on sugars and starches. When the yeast consumes the sugar in our bottle, it breaks it down to be used as energy. But like all living beings, waste products are produced when metabolizing food. When the yeast metabolizes the sugar, the waste produced is carbon dioxide gas and ethanol. The carbon dioxide gas floats out of the liquid into the bottle, producing bubbles.
The question for you, how do you think, in what flask the gas is released in most volume? Let's check. Now I put the balloon at the neck of these flasks. This process required a time. Let's wait. So, the main resource of obtained ethanol by fermentation is the starchy plants. They are sugar cane, rice, potato peel, wheat, corn, barley. All of these plants contain in a high concentration the starch. This is a polymer that contains many units of glucose. The whole industry process consists of three main stages. The first stage is the extraction of the starch. The grain is heated with hot water. The second stage is the breaking the starch into maltose. To conduct this process, enzymes are used. These enzymes are present in the malt, germinated barley. Enzymes cut the bonds between glucose molecules and form the maltose. Maltose is a disaccharide that consists of two residues of glucose. The third stage is the conversion of maltose into glucose. And finally, ethanol with concentration 15% only. Yes, it's very low yield of the reaction. Yeast is killed by ethanol in concentration above 15%. In this stage, yeast is added and the mixture is kept warm approximately 35 Celsius degrees until several days until fermentation is complete. During this stage, the maltose converts into two molecules of glucose, and glucose is converted into the ethanol. Obtained ethanol is impure and required further separation by fractional distillation. This stage allowed to increase the yield of ethanol to 95%. The whole industrial scheme of this process is batch process. In our magic laboratory, the time could be reduced. And so our experiment was finished. Let's see to our results. Does your expectation and assumptions of the results are justified with this experiment? Of course, at the first flask, we use 100% of sugar. At the second flask, we use the beet. So the concentration at the first flask of sugar is higher. And of course, the released volume of carbon dioxide at the first flask is larger. Let's compare the two main ways to manufacture ethanol. Use the following criteria: resources, type of flow chart of the process, rate of the reaction, purity of product, reaction conditions. First, think individually. And now discuss in pairs. Let's check your comparisons with the board. As you understand, in the industry scale, ethanol are made by hydration of ethene and fermentation. The more economically effective strong sides of first way of manufacturing ethanol are flow scheme, rapid run of the process, obtain pure ethanol. The fermentation use gentle temperatures and pressure, and very important renewable resources based on plant. Please solve the following task. Determine the percent yield of ethanol if 688 grams of glucose undergoes fermentation and 200 to 20 grams of ethanol is obtained. To solve this task, I give you 5 minutes. Okay, by the task for us given the mass of glucose is 684 grams. The practical mass of obtained ethanol is 220 grams, and we should find the percentage yield by this reaction. So the first stage we should compose our chemical equation. So as you know, from 1 mole of glucose in aqua form, we can obtain by the action of yeast the 2 molecules of ethanol. Also in aqua form, and 2 molecules of CO2 gas. So this is our chemical equation. The second stage, we should find number of moles of our given for us glucose compound. So for this purpose, we should use the famous for you equation: mass of glucose divided by molar mass. Okay, the molar mass of glucose is equal to number of carbon atoms in this molecule, 6 carbon atoms, multiplied by atomic mass of carbon atom is 12, plus the 12 atoms of hydrogen multiplied by the atomic mass of hydrogen, and plus 6 atoms of oxygen multiplied onto atomic mass of oxygen. Let's calculate. So 78 plus 12 plus 96 plus 2, 180 gram per mole. So now we can find the moles of glucose, which are given for us by the task. So the mass of glucose are given 684 grams divided by the molar mass 180. We obtain 3.80 moles. According to the equation, we should to construct stoichiometrical proportions. From 1 mole of glucose, according to reaction, we can obtain 2 mole of ethanol. So the number of ethanol moles is equal 3.80 multiplied by 2 . And overall 7.6 moles are obtained. The overall mass of ethanol is 350 grams. This is the theoretical yield. And last stage is percent yield. We can find percent yield by dividing 220 onto 350 grams and multiply by 100%. So the answer for this task, 62.9%. In the modern life, bioethanol is a widespread biofuel. Petrol companies manufacture different marks of biofuel. Letter E means the different portions of ethanol as the additives in the petrol. 50%, 30%, 50%, 85%. Such types of fuel is popular in Brazil and USA. Ethanol is commonly used to power automobiles, farm tractors, boats, and airplanes. Now please divide into two groups. One group think about strong advantages of using ethanol as a biofuel. Another group will take the opposite side of this statement. You should prepare the debate speech. Time for the preparing 50 minutes, for the speech 5 minutes, and polemic time 5 minutes for each team. Please check up your prepared speech according to the following success criteria. All statements, body language, and responses were respectful and were in appropriate language. All information presented in this debate was clear, accurate, and thorough. Every major point was well supported with several relevant facts, statistics, and/or examples. All arguments were clearly tied to an idea and organized in a tight logical fashion. The team clearly understood the topic in depth and presented the information forcefully and convincingly. Okay, thank you very much for your warm discussion. Let's summarize. Advantages. Complete combustion. It's very strong advantage of burning ethanol. Ethanol releases only CO2. Petrol releases, besides CO2, the monoxide and carbon. And usually you can observe the smoky flame, which is more harmful to the health. The next one advantage is it can be produced on site in local villages. As you remember, bioethanol required very simple equipment. The next one is a very strong advantage, renewable resources. It means that we can obtain these resources over and over again. Petrol comes from fossils. Fossils tend to run out eventually, supplying itself in a couple of decades. Also, ethanol is a good solvent, and these properties allow to clean engine and use it last longer. But also, bioethanol has shortcomings. If we compare with petrol, it's more expensive because it's requiring growing, transporting, fermenting, and distilling processes. Petrol requires only drilling. Another problem is a smaller heat of combustion of ethanol. It produces less energy. If we compare enthalpy of combustion of different substances as gasoline, petrol, coal, ethanol, and wood, ethanol has lower enthalpy of combustion than our usual using fuels as gasoline, petrol, and coal. Also uses farmland to grow the ethanol crop instead of growing the food crop. The main question, does we should use our lands to grow the ethanol crops, or we should use our lands to growing our food crop? Another problem is that using the bioethanol requires engine modification of cars. The designing of the new engines is very expensive. And also for dry continents as Africa, using water to grow ethanol crops, it's a big problem. Dear guys, how do you think, what ways could be increased using ethanol in the future? Now, scientists discuss about 2 points. The first point is find the way of obtaining ethanol from some weeds or plant wastes. And another one, design a new engine. The solving of these both ways allow to us obtain the bioethanol as a cheaper fuel. Now the time for self-reflection. Please consider 4 ideas from the lesson. Thank you for your attention. Our lesson finished. To prepare this lesson, used following FAB resources.